Okay. So Centipede parent is the base class from which the head and the segments derive from. Um, the way I have it set up, the parent um, it holds all the variables for both of the um, segments, the head and the segment. It also has various methods that both of the parts utilize, as well as a couple virtual methods, which the individual parts override. So the full centipede is essentially a doubly linked list. You see right there. Um, Having a pointer to its previous and next segment. Um, the structure was mostly useful for splitting and just passing states between the segments. So, spawning the segments is a little different than the other critters. So, to create the full centipede, the spawner just creates the head. However, it passes. Actually, I do it here. It passes an integer value, which corresponds to the length of the centipede. Um, the head will then recursively create segments, and in turn, those segments will continue to create segments until uh, the count is equal to 1, and then it'll stop. Um, yeah. Oh, also, so there's not a whole lot different between the head and the segments. So for initialization, for example, what I do is when I initialize a centipede head, I initialize the stuff that pertains specifically to itself, but then I call centipede initialize, which is a method inside of the parent class, which basically initializes all of the data that doesn't really matter. It doesn't matter if it's a head or a segment calling it, because they both have to initialize all this stuff anyways, um, such as the grid and its speed and whatnot. Um, so yeah. So so for movement, uh, the centipede relies on a finite state machine, much like the spider. Um, where is that? So yeah, right here. Um, it gets its move vector from its of its current state, and then it gets its next state. Um, it's per grid space. Okay, so now going into the actual state machine, actual states. Uh, so centipede behavior. This is a class that all the states derive from. Uh, all of the states override these functions, update animation, get next state, um, get distance counter. Oh, yeah, I guess so. Uh, so yeah. And then I store the static instances of each of the states. So just looking at one of the states, specifically get next state. So much like the other critters, I only check for a collision when I enter a new grid space. That's what collision check does. I have to do some variable updates for the head. I'll get more into that. So yeah, I recognize the head recognizes that it enters into a new state, and then checks to make sure that it's not colliding with anything, because this is heading left. It checks to make sure that it didn't hit the left boundary of the screen. It also has to check to make sure that it doesn't hit a mushroom. And then after it does these checks, it then it updates the segments. So yeah, after it gets its new state, it updates the segments using update segments. The head is the only segment which actually runs these collision checks. The segments just rely on this update segments to get their new state. So yeah, this basically just passes, actually, where is it? Yeah, it's right here. So it basically just passes the next state to the segments. It passes the states down to the segments. So first thing that happens in update segments is that it corrects the segment's position vectors. This just helps to prevent, so it calls update vars, does all this. This just helps prevent the segments from getting misaligned. When I didn't do this, sometimes, despite the fact that they were all using the same offset, they would just end up misaligned, like on top of each other, and they're not supposed to do that. So yeah. So after that, it'll then set its current state to equal its next state, and then it'll set its next state to the state that all of this is taking place in. And then it'll call update segments on its next state, on its next segment, and then just recursively pass the states down that way. So that's pretty much the finite state machine. So splitting. So when a bullet hits a centipede, is it here? Yes. Destroy enemy is called. And if the hit centipede has a segment attached behind it, it's P next, then it will, in a sense, turn the segment behind it into a head. So what's actually happening is, so there's a segment behind the hit segment, calls make head, that goes into parent class. I'll call make head. What actually happens is that it just creates a new head in the position of the previous segment, and then copies all of its data, into copies all of the previous segment's data into the new head's data, and then it'll relink this head to the appropriate nodes. And yeah, that's basically splitting, and that's basically a centipede as a whole.